All right, everybody. Good morning to you. We got at least 5 people online here, and good morning to Caesar. Good morning to Blanca. Good morning to everybody here. Whew. All right, getting colder, colder, and colder. I think it was raining. Is it going to rain this weekend? Anybody know? Don't know. Okay. Well, here's what we're going to work on. We're going to work on what's called the addition and subtraction formulas. So we do have some addition and subtraction formulas. Let me get out my notes here. But as you guys can see, maybe you want to copy that picture. I don't know. Let me find whatever. All right. Can't seem to find everything here, but that's fine. We'll just go with that. Okay, here we go. So we have this picture here. This is a circle here, and I want people to know that, there's kind of a very interesting relationship here. So let's start off with this particular address at P naught. We define that's 1, 0. So this is going to be a unit circle, so people know. Okay? So there's P naught. Now P1 is here, cosine S plus T, sine S plus T. This is the address here of P1. Now you might say, how did it get that address? Well, because they let this distance be T, this arc length be S. And so, the total distance is S plus T. So this is how they define that point, okay? So these points. Now, if you look at Q naught, we're going in the other direction. This is a distance minus S. Okay, and so Q naught here is defined this way. Cosine minus S, sine minus S. That's the coordinates, right? The XY coordinates here. And then Q1, you go, where's Q1 here? Cosine T, sine T. All right, now this is how we get to these particular locations. So these distances are what? Are equal. Okay, those distances are equal. You say, how could that be? Well, because from geometry, these are called chords of equal length. And so chords of equal length here have equal distances because they're equal length, okay? So in other words, these are the same here. And so we're going to go back a little bit to geometry now that we know these coordinates. Remember, you say, what's this D? Do you guys know what that D is? Anybody know what this D is, by the way? What's the D? This is the what? The distance formula. And that distance formula, D here, for the Q's. This is for the Q's. So we focus on Q naught and Q1. So this is going to be Q1. Looks like it's going to be, if you guys remember the general distance formula, let me write that down, I guess. From geometry, right? And that's when you have 2 points. Like here's X, Y, and here's a second point here. Okay. Distance formula, square root x2 minus x1 squared, y2 minus y1 squared. There you go. Okay. distance formula. Okay, and it's based on these coordinates. So, okay. So you say, what about this Q1? Well, this is going to be cosine, it looks like this here. Cosine t minus, right? So cosine t, q minus cosine minus s? Yeah, what am I looking at here? Okay. Minus cosine minus s squared plus, because it's not going to fit. So this is q naught q1 sine t minus sine minus s, right? So let's try that out. Okay. So you say this is the q, this is the q's here, using the distance formula. And so I'm going to put down here, this is for the q's. So now I'm going to say, here's my distance formula here, because cosine minus s, you guys know what this is. What's that going to be? That's just cosine s, is that right? Sine minus s is minus sine s. So we can simplify this a bit, meaning cosine t minus cosine s, everything squared, plus sine t plus sine s squared. So this is for the q's, okay? So you say, what did I do? I just used the distance formula for the q coordinates. Now we're going to do the same for the p coordinates. So you say, well, what does it look like for the p coordinates? Right, here's our distance formula. P coordinates. Cosine s plus t minus 1 squared. Sine s plus t minus 0. This is for this. Okay, so this expression up here is saying that these things are equal. Okay, so, all right, so now what I have to do, since they're equal, is this. This, the same as what we have here. Okay? So what you're now going to see here on this side, I would say, well, we're going to have to use what? You guys remember this? We're going to have to use FOIL here. So you got this a plus b squared is going to be a squared plus 2ab, right, plus b squared. Or if you say a minus b squared would be a squared minus 2ab plus b squared. Wow, so you're going to use FOIL here. So we're going to have to use FOIL where? Here, 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 believe it or not. Okay, you guys okay with that? So for the first one in the upper left, we're going to have to do this same process here. So that'll be cosine squared t, right, minus 2 cosine s cosine t plus cosine squared s. And then we're going to do that for the sine now. So this will be plus sine squared what, t? Okay. Plus 2 sine s sine t plus sine squared t. And then the lower left corner, you're going to get what? Cosine squared s plus t. Now that's going to be minus 2, right? So it's just be minus 2 cosine s plus t. That lower left corner. And this will be plus 1. Now we'll do the lower right corner here, and that's just simply sine squared s plus t. So that's plus sine squared s plus t. Okay? So I want everybody to know I just used this FOIL formula in all 4 locations here. Okay? This is the algebra part. And now I'm going to use this fact here from trig. I'm going to say cosine squared theta plus what? Sine squared theta equals 1. Okay, so what that's going to mean now here is I got a cosine squared t. What else do I have? Oh, yeah. Cosine squared t, sine squared t, that gets replaced with a 1. Okay, so this is my first 1. I got what? Cosine squared s. And then there should be a sine squared s somewhere. Yeah, I think I wrote it sine squared t. There you go. Sine squared s over here. So this is supposed to be an s. And that's going to give me my next 1, right? So we got a 1 there. Okay. So far, it looks like, what do I have here? Here's what we have. 2, we got 1, 1, minus 2 cosine s cosine t plus 2 sine s sine t. Now, what does that equal? Well, over here, we're going to get rid of this, and that's a 1. Okay? So we have 1 minus what? 2 cosine s plus t. And this already has a 1 there too. So there's a plus 1. Okay? So what you now have, 1 plus 1 will be 2. Okay, so I'm saying there's another 1 out here. So you say, what does that do now? Well, we can get rid of the 2's here, because if 2's are equal, on opposite sides, and now that what that does for you, it gives you this minus what? 2 cosine s cosine t plus 2 sine s sine t, and that's going to be minus 2 cosine s plus t. Okay? And I can actually change the signs. If I say I'm going to multiply everything by what? A negative 1, that changes the signs. Okay? And then I guess I'm going to divide everything by 2. You say, what does that do? That gets rid of the 2. So then what I'm left with, I'm going to read it, Jennifer Lopez is J-Lo, blah, blah, blah. J-Lo is Jennifer Lopez. Cosine s plus t now becomes cosine s cosine t minus sine s sine t. Now, your book likes to use a and b. It doesn't matter if you use s. It doesn't matter if you use t. You'll see different versions. And so here's what we're saying. Cosine of a sum, A plus B, is cosine of that first A, cosine of B, minus sine of A, sine of B. Okay, now if you say, what in the world is this? Focus on this. This is angle A, and this is angle what? B. So what did you just do? This is cosine of a sum. And how you find cosine of a sum is take cosine of A, sine of A, the individual angles, cosine B, sine of B, and now you actually subtract those. So I just want you guys to know this is a formula for what's called a sum formula. And so what we have actually is this is the sum formula. And then you might say, well, do you have a difference formula? Yes, we do. Okay, if we now replace, just so you guys know, this B with like minus B. Okay? What you end up getting is cosine of A plus a negative B is minus B becomes cosine A cosine minus B. Okay? Minus sine A sine of minus B. So what's cosine of minus B? Cosine B. What's sine of minus B? Minus sine B. So all together now, here's what you get. You get now what? Cosine A minus B is cosine A, cosine B. This is minus a minus plus what? Sine A, sine B. And this is a what? Difference formula. Sum formula, difference formula. So if you have this what? A, B, there's a difference now. That's why they call it the difference formula. It's found just by finding the individual angles. Right? Now this is going to be a plus. Okay, you guys okay with that? Pretty good. Now, I just want you guys to notice something here. Let's know. I'm not going to go through that derivation, though. But in your book, you also have sine. You can prove sine, a sum formula for sine as well. So you have sine of alpha plus beta is sine A cosine B. plus cosine A sine B. Okay? And then you also have the difference. Doing the same kind of thing. If you change B to minus B, and using even and odd properties, you get sine A cosine B minus cosine A sine B. Plus plus minus minus. There you go. Okay, so you have these sum and distance formulas, sum and difference formulas for both sines and cosines. Okay, so just so you guys know, and then you also have the tangent, and, you know, so we're going to say, what about the tangent versions? Well, tangent A plus B, I'm just going to remark here. Yeah, we can generate the tangent formulas for you guys so we can prove them. Anyway, so if I said to you, let's look at tangent, we can do some of that. We know it's sine A, cosine B, cosine A, cosine, sine B. Okay, now cosine A plus B, we already have that up here. Cosine A, cosine B, right, minus sine A, sine B. So we're looking at this one here. Minus sine A, sine B. Okay, so we already know that. And then what we're going to do here is the following. Okay, because I'm going to now divide. So let me actually just do this. I'm going to divide every term by cosine A, cosine B. So I can do that, algebraically speaking. So this is cosine A, cosine B. Okay, and now you might say, I think I recognize sine A over cosine B. This portion here cancels. I think I recognize sine B over cosine B. This portion cancels. This cancels completely. And you may recognize these two as well. So you get what? Sine over cosine, right? What's sine over cosine? Do you guys know? It's tangent. So you get tangent A plus tangent B. 1 minus tangent A, tangent B. Tangent A plus B. Anyway. And then similarly, you can deduce the difference formula for tangent. Okay? So I wanted to prove this stuff for you guys here. And you just replace the b with a minus b, and you get tangent A minus tangent B now, right? And the sign switch, 1 plus tangent A tangent B, okay? Because you're just replacing here b with a minus b. There you go. Okay. All right, tangent of a sum. This is the sum formula, and then this is the difference formula. Okay. And I should have put it in black just to be consistent. All right, so there you guys go. And you go, oh my God, we got these formulas. And so remember, I think I said something like this here, right? I said it the other day. Like, let me give you guys an example. If they said to you to evaluate, here's kind of the essence of this. Sine of 15 degrees, okay? Now, maybe I didn't say that to you. I apologize. Now I remember. I think I said it to a calculus class. Okay? I said it to a calculus class. Calculus students asked me, hey, how do we evaluate sine of 15 degrees? And then I said, oh, remember back in trig, you did the sum and difference formulas, right? Well, guess what? We're in trig. We'll do the sum and difference formulas. 15 degrees can be written how? Do you guys know? I can write 15 degrees as 45 degrees minus 30. Is that true? So here's what I mean. This is how you use it. This was the reference to those students here. You're going to use the difference formula. Okay, here's that first angle here. Orange, green. Okay, now you say, what's sine of a difference? Well, there you go. It's sine A cosine B minus cosine A sine B. So it's sine cosine minus sine 45 cosine 45 minus sine 30 cosine 30. Sine A cosine B, right? So go back, sine of a difference. I have it in my copy. Sine A cosine B minus cosine A. Cosine. Thought it looked different. Thought it looked odd. Sine, cosine, cosine, sine. Sine, cosine, cosine, sine. Do you guys know what sine of 45 degrees is? Is that square root of 2 over square root of 2? Do you guys know what cosine 30 degrees is? Do you guys know what that is? Well, here's my point. Remember I've said in the beginning, you only have to know two special triangles? Remember that? That's what this comes down to. Just only two special triangles, 45. 1, 1, square root of 2. What's the other one? Right? 60, 30. 1, 2, square root of 3. So what's cosine of 30? Remember the definition of cosine? Is that square root of 3 over 2? Is that right? And so all this does is it's gonna come down to just special triangles. That's it. So then you go, okay, what's this gonna be? Sine of 30 degrees, right? What's sine? Sine of 30 is gonna be 1/2, right? Cosine of what? 45 is square root of 2 over 2. Double check. All right, you guys okay with that? You guys see my point? It's just going to come down to two special triangles. So even still, you might say with these sum and difference formulas, you still can't do a lot of other angles. I can't do, for example, you might be able to do a lot, but you can't do all real numbers. You can't do for every, if I said what's sine of 32.8 or, can't do that. You need other tools. So it's still a little bit limited, but you can do more. So here's my point. This is going to be now, if you said, how do I answer this? Well, you should see there's square root of 2 over what? 2, right? Times the square root of 3 over 2 minus square root of 2 over 2 times 1/2, right? So we're going to get what? Square root of 6 over 2 minus square root of 2 over 4. I'm sorry, that's 4. And you might say, I'm out of space here, but I want to remark, let's just factor, okay? So you might even see this. Square root of 6 minus square root of 2 over 4. There you go. Okay, this is just like a first example of this. Now you could do tangent, if they said to you, well, what about if they asked me cosine? You could do cosine. But what about if they gave you tangent 15 degrees, right? Same kind of question. You already know to write tangent how. You can write tangent as 45 degrees minus what? 30 degrees. Okay, and you're going to use that, that distance formula, or no, I'm sorry, not that distance, the difference formula, right? And say, what was tangent of a difference? Tangent A minus tangent B. Tangent 45 minus tangent 30. 1. plus tangent 45 tangent 30. So you say, what's tangent of 45? Do you guys know what tangent 45 is? 1. What's tangent 30? Is it 1 over the square root of 3? Which will be over 3. Yes. Divided by 1 plus tangent 45 again is 1. Tangent 30 is square root of 3 over 3, ladies and gentlemen. Okay? So 1 times anything is itself. Now, here's what I recommend, right? You might want to say, what do I do with this now? Well, remember, you have a denominator in both cases here. This is a 3, okay? So you can replace that 1 with what? 3 over 3. 3 over 3. Threes cancel. Okay, if you do your division algorithm, those 3's cancel. What does this come back to equal? And you're done. Just so you guys know. You're done here. Well, I was going to get to that. I just want to kind of let you guys know, notice this. You might see, like, this is tangent of 15 degrees, and you go, wow, that's kind of an interesting representation, right? There's some calculators that are symbolic, and you go, well, I put this in, and you know what they did? They rationalized the what? Denominator, okay? So I got to let you guys know some truth here. I like telling the truth. That in some sense, if you got 3 minus the square root of 3 over 3 plus the square root of 3, you don't have to rationalize. You know, you don't have to. Like if you've done enough, and there'll be some books that give that answer, and you go, oh, wow. As long as they know you know how to do that. But if you're in another environment and you go, I looked at the back of the book or blah, 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 they got what? They got this 9 minus 6 square root of 3 plus 3 over 9 minus 3, right? So you get what? 12 minus 6 square root of 3 over 6. And you say, I looked in back of the book, they got 2 minus square root of 3. I think that's what you get, right? So there's a more simplified version of the answer, you know? But that's where they got it from. They rationalized the denominator. That's all. So you might just see, you know, different answers. You go, oh my gosh, you know, I got this. Well, if you rationalize the denominator, here's what you get. And I should be saying by law, hey, rationalize the denominator, you know. But I have seen, like in other books, they'll just leave it as is. But, you know, it is good to have a more simplified version. So, you know, there's a lot of other angles you can get by hand, all without a calculator. And I think this is kind of just the exercise for you guys to start to know you do have some in different formulas. All right, you guys okay with that? Easy breezy, lemon squeezy. You say, Mr. Judge, easier said than done. Let me give you guys a few examples. I want you guys to think about this. Try cosine 195 and sine minus 165. Try to find those angles. And I'll give you guys some time to do that, okay? All righty, let's get out our clock. let's see. 225 degrees minus 30 degrees. You could do that. How about this? Could you use 150 degrees plus 45 degrees? You guys see what I'm saying? So you could use, I'm going to try to remember to see what I used. You could even use this. I used 240 degrees minus what? 45 degrees? Yeah. Okay, you guys okay with that? You could even use a sum formula like, what? It's weird.
135 degrees plus 60.
Yeah, that's what I was going to say. 135 degrees plus 60 degrees. Right? So pick your what? Pick your poison. Which one do you guys want to use? And then over here, I'm going to say something like this. You can say, this should be minus sine of what? 165 degrees. Is that right? And so, because sine is what? Odd, right? So what would you use here? I could tell you for 165, I use 225, right? Minus 60 degrees. But similarly, you can do even, 150 degrees, by the way, plus 15 degrees. If you said, hey, you already found sine. If you found sine here, we didn't. We found tangent. But if you found, sine, then you could use that because you already know what it is, right? You guys see what I'm saying? If you use coterminal angles, yeah. You could do that because it's coterminal. So the question is, can I just add 360 here? What do you get anyway? You can say this is equal to 195. And then again, you say, well, I'm in that same what? Situation here. And maybe you're going to use whatever, 225 minus 30 or something, right? Right. So you could use coterminal as well. I'm not saying that that's bad. It's not. It's just different. But, I would just use even and odd and call it a day. But you can definitely use coterminal angles, without a doubt. Okay, so anyway, let's do, which one do you guys want to do? We've got so many options. Sometimes you get option paralysis, right? 225 minus 30. Okay. So cosine of a difference. What's cosine of a difference? You know what cosine of a difference is? Yeah. Cosine A, cosine B plus sine A, sine B. Cosine, cosine plus sine, sine. So it's going to be cosine 225, cosine what? 30, plus sine what? 225, sine 30. And so you might say, I can get cosine 30 pretty quick. Go back to your special triangle, right? What's cosine 30? Square root of 3 over 2? So you say, I could get square root of 3 over 2. And this is what, 1/2, I think? Is that true? Sine 30? Just go back to your special triangle. Like I'm saying, this is the amazing thing. You just need to know 2 special triangles. And I'll say that every, and we'll work on that and go get that. Should probably put that in every test. I always thought to myself, ask that question on every test because it shows up. You see what I mean? What about this other one, though? Cosine 225. Do you guys remember how to get that? Yeah, we're going to have to use, I was going to get the picture out. Come on. So 225, where's that angle? Do you guys know what I mean? It's going to be quadrant 3, right? I'll get this out. And so remember, can't even get the right tools. So we're going to rotate, and that'll be 225 degrees. This over here is going to be what? 45 degrees. Okay, so you might say, I need to know what? What's cosine 45 degrees, right? Square root of 2 over 2. But what does that imply about cosine of 225? Right? We're going to have to use all students take calculus. So that means cosine of 225 degrees is negative what? Right? Isn't it negative? Why is it negative? It's in quadrant 3. So you just need to know 2 special triangles, ladies and gentlemen. So minus. You guys see what I'm saying? Minus what? Square root of 2 over 2. And then what's sine? Well, sine 45 is square root of 2 over 2. And so sine 225 is what? Negative square root of 2 over 2. Is that right? You guys okay with that? So what do you get now? Minus square root of 6 over 4 minus what? Square root of 2 over 4. And so if you factor out, you get what? Minus square root of 6 plus square root of 2. Over 4. Because you just factored out the negative square, negative 1 over square root of 4. So if you look in back of the book and you see that answer, either I would be fine with either personally, just so you guys know. I'm just so happy you got all the way there, square root of 6 over minus square root of 6 over 4 minus square root of 2 over 4. So, and then you go, okay, what about this other one? sine of now, you did coterminal. So if you want to do this, it's a difference formula again. So you have to go sine of a difference. So you got to get that difference formula here. Sine A cosine B minus cosine sine. Sine cosine minus cosine sine. So it's sine cosine minus cosine sine. Okay? Sine cosine minus cosine sine. Right? So it's cosine and sine of 30 degrees. Go back over here. Cosine, what's cosine? Square root of 3 over 2? 30 degrees. Sine is what? 1/2. And then sine of 225, I think we had that already. Isn't this minus? Okay. Cosine 225 was minus as well, I think. Yep. So already had this. Again, if you have this here, that's fine. You can factor out like a minus 1/4. So you get square root of 2 minus square root of 6 here over 4. You just switch the terms. If you want to factor out that minus 1/4. And write that leading term as positive. So there you go, ladies and gentlemen. There it is. Yeah. Yeah, I'm sorry. I meant to put square root of 6 first. And that's square root of 2. Sorry about that. There we go. Good job. There it is. Okay, and then just to kind of, what if they gave you tangent of 11 pi over 12 here? Okay. Now, for sometimes for radian measure, students get a little what? It gets a little more difficult for people with radian measure, in my opinion. And you say, well, why is that? Well, you could use sum or difference, right? So what do you guys know? I would say you guys know, like, for instance, pi over 4, pi over 3 angles, pi over 2, and so on, right? 5 pi over 4, 2 pi over 3. You guys have even like pi, multiples of pi. So how would I write 11 pi over 12 as a sum or difference? You can kind of cheat. What is cheating? What is that as a degree? I mean, there's no law that says you have to keep with radians. Okay, you guys know what I'm saying? You might say, I like converting to degrees. Well, what is this as a degree then? Right? What does that become? If you wanted to convert, is that 11 times 180 over 12? You guys know what I'm saying? So what angle is this? You said, I'm gonna look at this way. What angle? If we could wake up our TI, say, wake up TI. I don't know. I guess it's kind of like I said, as it's getting colder, I get to sleep better. I don't know about you guys. I'm like, wow. $165. Oh, did we do that one already? Boy, so 165. I'm gonna buy lottery tickets. I'm gonna get the number 165. Anybody win that big lottery? No. Oh, you guys better pray I don't win. You might show up one day and no one's here, and you go, "Oh, I know what happened. He won the lottery." I won't even clean out my desk. You guys know what I mean. I used to think I would and all this stuff, but no, I think I'm not. You know, and the irony is, people think, "Wow, Mr. Judge, you feel that way about students?" And I'll say, it's not the students that make me feel this way. It's not students at all that make me feel that way. It's all the others, without mentioning the details. So you would leave? I go, I think I would. Again, it's not the students that are the problem. I don't think the students are the problems, if you guys want to know the truth. It's not that. Students have never been the problems. Anyway, 165. What do we do? Hey, how about 120 plus 45? What do you guys think? I'll do 120 plus 45. I like that. So if you're kind of a little nervous, let's say about radian measure, just convert to degrees. That's what I would do. You guys know I would convert because I'm more comfortable. That's what I would have done as a student. I'd be like, oh man, I'm converting, you know. And you got tangent of a sum. So I go back. And remember, on a test, am I going to give you that formula sheet? Yes. So you have the formula sheet on your test. Okay, you don't have to memorize this one. Tangent A plus tangent B, 1 minus tangent A, tangent B. So I'll give you the formula sheet. So take tangent 120 plus tangent of what? 45 is 1 minus tangent 120. Tangent 45. Okay. Now, tangent 45 is simple. Do you guys remember that one? That's 1. Okay. But we need to know tangent of 120. Now, get out this, all students take calculus thing. $120. Okay, 120. I think 120, isn't that? This is like 30 degrees, is that right? 90. This would be 120 degrees. So it's a quadrant 2 angle, only sine's positive. So the reference angle is what? 30. So I need to know what tangent 30 is. Because whatever tangent 30 is, tangent 120 is minus that. So tangent 30 is what? What's tangent 30? It's 1 over the square root of 3, but when you rationalize, square root of 3 over 3. So this is square root of 3 over 3. This will be minus square root of 3 over 3. Okay? Tangent 30 is square root of 3 over 3. Tangent 120 is minus. Yeah. So what do we need? This is minus. Minus square root of 3 over 3. Minus square root of 3 over 3. So altogether, so I do the same trick. Replace 3 or 1 with this and switch the order. 3 minus the square root of 3 over 3 minus the square root of 3 over 3. Let me double check. So it's 3 minus the square root of 3 over 3. That, is it 1? Could it be 1? Did I make a mistake here? Oh, it's plus down here. It's plus, sorry. Minus and minus makes that a plus. Okay. Okay. So again, we can say 3 minus the square root of 3 over, right? Nine. No. Right? FOIL here. 9 minus 6 square root of 3 plus 3. Double check. And then that's going to be 9 minus 3 down here. Two minus the square root of 3. Was that what we got earlier? That's weird. Did we do this one earlier? Did we do tangent of 165? Let's double check. How do we double check? Do you guys know? What if you said, I want to double check on my homework, tangent of 165. Go to your TI. Tangent 165, okay? And then I get 2 minus the square root of 3. Same.
The one we did earlier is a tangent 15.
Tangent 15. So let's try that one. Where's tangent 15? Tangent 15. Okay, so this one, we're going to find an error here. Let's find our error. I know I should have never went to Starbucks. That coffee never wakes me up. Okay, 120 plus 45 is pretty good. I know where we made a mistake. No, did we? Let's double check. Yeah, that is negative square root of 3 over 3 plus 1. Okay. There we go. Now, 1 minus makes it 1 plus. Okay. Okay, so I'm right over here. So it's 3 minus the square root of 3 over 3 plus the square root of 3. Is that what we got earlier? 3 minus? Okay. Well, anyway. We're out of time, and I'll have you guys find the error. All right? Should we make that extra credit? 5 points extra credit, whoever finds it first. Just send it to me, and we'll see you guys when. See you guys later. Have a great morning. I'll put homework in Canvas. Okay, excuse me, you guys. Sorry, I don't mean to clear my throat as a start here. First thing you guys hear this morning. Anyway, good morning to you guys. We got at least 4 people online, and the rest of you guys here. I just want to announce we got 2 winners. I decided to give 2 students winners to the extra credit situation. So we want to thank Shirley Leva, who's in our class. Thank you, Shirley. And Alice Yu. We want to thank both of you guys for finding that error as, old man Judge drinks his coffee. And anyway. And it was a very simple error, in all honesty. The problem we did yesterday was, remember, this is our reference angle. Okay, our reference angle is 60 degrees, not 30 degrees. That was the issue. Okay, so when I go back to the 60-degree angle, or we go back to the 60-degree special triangle here, right? Hey, where are you, 60 degree? There you are. What did I need? Tangent of 60 degrees? Was that it? So tangent of 60 is opposite over adjacent. So it's the square root of 3 over 1, right? Tangent of 60, you guys remember that? And that's just the square root of 3 now. So you say, okay, this will be what? The square root of 3. Now, that's for tangent 60. Now, 120, though, is in quadrant 2. So that means all students take calculus. Sign is positive, and this will be negative minus square root of 3 now. Okay, so you have to put minus square root of 3. And that's for tangent of 120. So if we go back here, we say this is now minus square root of 3. This is minus square root of 3. And ladies and gents, there we go. So, okay, let's see what we get now, right? This will be what? Minus square root of 3 plus 1 over 1 minus a minus, that's 1 plus square root of 3. And so it looks like it's going to be 1 minus the square root of 3 over 1 plus the square root of 3. If I switched my terms here. Right, ladies and gentlemen? So what do we do now, ladies and gentlemen? You say, well, we have to rationalize that denominator, right? So, okay, we're going to do what? Let me wake up the TI because I know we'll be using that. So here's rationalizing the denominator now, okay? You write this as 1 minus the square root of 3, 1 minus the square root of 3. Okay, you guys okay with that? So in the denominator, you end up with simply 1 minus 3. Now, what do you guys use on top? Do you guys know? You want to use what? Foil here. So what do you get for foil? You get now what? 1 minus 2 square root of 3 plus, is that 3? Okay, so we get 4 minus 2 square root of 3 divided by, this will be negative 2. Okay, and so, you divide both terms by the negative 2. And so we get negative 2 plus the square root of 3. Okay. Is that right? Is that what you guys get? Double check. So numerically, remember what this was about. This was about demonstrating what tangent 165 would be, or out here, this will be the same thing. So it's negative, what was the answer? Negative 2 plus the square root of 3. And that, like we said, measured 165 degrees. All right. So, ladies and gentlemen, here's the deal. Tangent 165, we know is numerically, this value here, negative 0.26798, right? And then you say, what was that? Negative 2 plus the square root of 3. Notice what you get. You get the same exact what? Answer. So both Shirley Leva and Alice Yu, thank you guys very much because you verified the use of this sum and difference formula here. Okay, now, I kind of personally, like I said, this to me, it's good to know these sum and difference formulas. It's good to know that you can get, evaluate these other trig, these other angles. Okay? And, you'll see a few of those, I guess. And this is kind of what we want to do. You want to look at a few more? Let me go back and look at our book. Should we warm up? Get nice and warm on this day. This nice cold day. Let's get warm. Anyway. Good for you guys. Okay, so let's have you guys do the following here. Let's get nice and warm. Okay, I want you guys to, what do they say? Use the addition, find the exact value. So you're going to determine the exact value. Okay, so give you guys a few minutes to do a nice warm up to find the exact value using those kind of formulas here this morning. Let's get out the clock here, okay? Let's get out this clock. Let's see what you guys get. All right, ladies and gentlemen, here you go. You guys ready? You know, there is a lot of angles you can use. Is that right? For 15 degrees and for 105. I mean, I don't want to dictate to you guys which ones, but what did you use? What do you guys think you can use? You can say 45 degrees minus 30. Is that right? Are there any others? I don't know. What do you guys think? I mean, did anybody else try any other angles? You could do 60 minus 45. Is that right? Because, you know, even if you said, I did it different, it's okay to do it different as long as, you know, this is the beauty of math, that as long as the difference is what? 15 degrees, you can do that, okay? Anybody have any others you could use? I mean, there's many. I would say, you know, you could even use 90 minus 75, but why would that probably be a longer way? You guys, now you have to find the 75. Is that right? So I just want to kind of remark that, yes, although you can use any difference, there's probably a more efficient approach, right? Anyway, good job. What about the 105? Oh, you guys do that there? 60 degrees plus 45 degrees? That's good. You can do that. Certainly good there. That's going to be 105. Okay, and then what if you said, what if I did this 90 degrees plus 15? You can, but not as efficient. Is that right? So I'm going to just cross it out, but just not as efficient. You can. You'll spend time trying to find that 15 degrees. So it's just an issue of being efficient. So, you know, ladies and gentlemen, what I'm going to do this morning then, I'm going to remove this one, and I'm going to keep this one here just for demonstration purposes. Because notice this, I'm just working with 60 degrees and 45 degrees in both of them. That's all. No other reason. But what else you guys want to remember on your test? What will I be doing here? Okay, on your test, I'll be doing what? 241. That's you guys. Oh, no, I'm sorry. I have to go back. What did I do? You guys have this sheet. Is that right? You guys remember? I'm going to say you guys can use that sheet. So, so which one are you going to look for? You guys remember? Where are they at? Oh, the sum and difference formulas. They're to the right. Is that right? So we say, yay. So, you know, just want you guys to be aware that you guys get to use these sheets, okay? And so what do you guys get now? This is going to be now cosine. We got to find cosine of a difference, right? So I'll say I'll do it this way. Cosine of 60 degrees minus 45 degrees, okay? Which one do I use? What is the minus, right? Do you guys see it there? What's it going to be in this sheet? It's cosine. Cosine 60, cosine 45. Cosine. What's it going to be, plus or minus? Can you guys read it? Then you have sine. Which one is it, plus or minus? It's going to be plus. Is that right? All right, you guys see it? You see what I'm saying? It's going to be plus. So you're using the 60 is here and here, and then the 45 is here and here, right? That's how you go about this, ladies and gentlemen. So it's cosine of 15 degrees. So up here is going to be the 15 degrees here. Okay? So now you just have to know, right? Special triangles. What's cosine of 45? If we go back there, I think that one by now you guys should have that memorized, right? Square root of 2 over 2, if I can find my special triangles. Where are you, special triangles? Hey. Yeah, where did they go? Oh, I don't know. Where's this? Okay, there we go. You know, it's 1 over the square root of 2 or square root of 2 over 2, right? And then what else did we need? Cosine of 60 and sine of 60, is that right? So let's do this here. Let's write this down. Cosine of 60 is what? What's cosine 60? Square root of 3 over 2. What's sine of 60? I'm sorry. We're going to make another mistake. 1 over, we get square root of 3 over 2. Okay? So write that down. Oops, let's not bring the triangle. Okay? So let's write this down. This is going to be now what again? 1/2. This was square root of 2 over 2. Sine of 60, what do we say that was? Square root of 3 over 2. And then sine of 45 was also what? Square root of 2 over 2. So we get 1/2 times the square root of 2 over 2 plus the square root of 3 over 2 times the square root of 2 over 2. Square root of 2 over 4 plus square root of 6 over 4. Is that right? And sometimes they just distribute these answers. Like, they'll just write it this way. Okay, you guys okay with that? What do you guys think? Is that pretty good? All right. Now, what about the next one? What do you guys think about the next one? Sine of 105. We got to do sine of a sum. So if we go back and look at the sheet, this is 60 and 45 now, right? So let me write this down. Sine of 60 degrees plus 45 degrees. Sine of a sum. What is that going to be? Sine cosine? Now, is it plus or minus? Plus. So this will be sine cosine plus cosine sine. Is that true? Now, remember, what do we always know about this? This is O square root of 2 over 2. Is that right? And this one's going to be also what? Square root of 2 over 2. But now we need sine 60. Do we need sine 60? Oh, we got sine 60. What's this? And then what's cosine 60? 1 over 2. So what does this become now? This is what? Square root of 3 over 2. Square root of 2 over 2 plus square root of 6 over 4 plus square root of 2 over 4. Is that right? And then you say, well, what's this going to be? The square root of 6 plus the square root of 2 over 4 here. Now, is that the same answers? So cosine 15 is the same as sine of 105? Should we ask Shirley, did we make a mistake? No? Thank you. Let's ask. Let's find out. What in the world is going on? What's going on with the world? What do we get? Cosine of what? 15. Okay. Sine of what? And didn't we say, what is this going to be? Square root of 2, right? Second, square root of 2 plus second square root of 6. Let's get that out of there. Close the parentheses. Divide by 4. So, okay. It looks like we're on our way. Is that right? You guys okay with that? Nice. What do you guys think? Pretty good? I don't know. I think it's interesting. The sum and difference formulas are always interesting. But, you know, one of the things that I enjoy about this idea, just so you guys know, is, you know, this is another application of the sum and difference formulas here. In other words, if you're ever given an expression of this form, A sine x plus B cosine x, okay? I'm going to prove to you this because sometimes, like in science, they may have a physical application where A sine x plus B cosine x, okay? You have to graph something like that. And you go, how do I graph a sum? You got a constant here, just so you guys can see this. Here's a constant A, and then here's a constant we call B. Okay? And of course you got, you know, these are constants, A and B, and you got to graph this. You go, how in the world do I graph the sum of two functions? So this is actually just really the sum of two functions. So there is a way to do that. We got a way to do that, right? You guys see, you say, what are the two functions? Well, it's A sine x and then B cosine x. So there's a lot of physical applications that you study in science that's really the sum of two functions here. And the idea is to this. This is what we're going to do here. You're going to convert it. You're going to convert via the, you know, sum and difference formulas. To a single sign. And that's the idea. You convert to a single sign here. So let me share with you guys how that's done, okay? I'm going to give you guys a fact, and I'm going to prove it to you guys. You say, what's the fact? If, well, get rid of the word if. This statement is equivalent to. How does your book want to write it? K sine x plus phi. okay, where k is the square root of a squared plus b squared. Okay, and what else? Cosine phi is defined to be a over k, and sine of phi is b over k. All right, so you're going to get these values here. This is a, this is b, and let's color k, I guess gold or something. See this k? This is what k is over here. Okay. So let me prove this to you guys. You go, you can prove it? Yeah, we can prove this. Here's a proof. We're going to start with a sine x plus b cosine x, right? You see this statement? Here's what we're going to let k equal the square root of a squared plus b squared. Okay? Then this equals k over k. Remember, k over k is going to be 1, okay? I'll put it this way, though. This will be a squared plus b squared divided by a squared plus b squared. This is the number 1. So 1 times anything is itself. So I can say, you know what that is? This is going to be a sine x plus b cosine x. Because remember, if we're going to let this portion be k, this is k over k, which is 1, just so you guys know. Okay? So in other words, we don't change the equality there at all. Now, I'm going to distribute here. I'm going to leave outside the numerator, and then that's going to distribute to the denominator. Right? Okay? Now, here's what I'm going to do. I'm going to change my color. I'm going to let you guys know. I want you guys to notate something here. I'm going to note. I'm going to create a triangle here. Here's your x-axis. Here's your y-axis, right? And call that angle phi. This is a right triangle. So I'm going to let this be my A value and this be my B value here. Okay, so we're saying orange and green, I guess. Okay. So here's my constant A, and here's my constant B, and here's the angle phi. Now, you guys know by Pythagorean theorem, isn't this going to be K? This is K, right? So in terms of phi, do you guys want to tell me this? Let's say this. Do you guys realize something here? That what's the definition of cosine of phi? Do you guys know? Yeah, it's adjacent over what? Hypotenuse. That a squared plus b squared, because that's what k is, right? And then sine of phi is going to be opposite over what? The a squared plus b squared, or k. So we can write that as a over k, right? Or b over k. Okay, you guys okay with that? That's the angle phi. And then you have your colors, because this is from right triangles here. All right, and you go, okay, well, what does this mean? Well, if I say a square root, oh, you know what this one is? This one's right here. See this here? This is gold. That's cosine phi. And then what's this? So silver and gold. Isn't that sine phi? Right? You get sine phi? So far, here's what this equals. Okay, so far, this equals what? K cosine phi sine x plus sine phi cosine x. Okay, you guys okay with that? You said that AB sine x plus b cosine, this is what this equals? Yes, it does. Okay. Now, if I go back to the sheet here and I ask you guys, I'm losing colors. Pretty in pink. Do I recognize cosine phi sine plus sine cosine anywhere?
It's the sum formula of sine.
Right. Cosine, where is it? Cosine sine plus sine cosine. You know what that is? That's equal to, I think that's the first one. Is that right? Okay, you guys see, is that the first one on top? So what I'm saying is that this equals k sine x plus phi. And that's what I wanted to prove here. Okay, so let's go back and you say, what are we really saying here? Well, we're saying that this statement is valid. Easy breezy lemon what? Squeezy. Oh, come on. Okay, you guys okay with that? So then the question becomes now, what's going on here? They're going to say the following now as examples, okay? They're going to say what? How can we write, let's kind of keep it a little simple. Write sine x plus cosine x. How about if we just write the instructions up here? Write as a what? A single what? Sine. Constant 1, constant 1. Do you guys know what that means? Here's what this means. This is A, and this is B. Would you guys agree with that? Oops, wrong color. Is that A and B? Okay, you guys okay with that? Okay, what does it mean about K then? Right, K, isn't K defined to be what? 1 squared plus 1 squared because it's A squared plus B squared? So K would be 1 plus 1. Is that K is the square root of 2? Okay, so far so good. So you say, what do I need? You need the value for K. You got K. What else do you guys need? This is the Greek letter phi. Because if you're going to use this statement here, up here, okay, which you got as a single sign over here, you got the K value over here, right? Now you want to know what phi is. So what is phi? So how do you guys think you're going to get phi? Do you guys know how you're going to get phi? How do we get phi? It's very simple. Go back over here. Go back and use these formulas here, okay? What do I mean? That cosine phi, A is 1. What is K? Square root of 2. And then sine phi is what? A is what? Or B is also 1, square root of 2. Let me also make a big remark. Let's notice something here. Cosine of phi is positive. Sine of phi is what? Positive. What does that mean about phi? Phi is in quadrant 1. Is that right? Not only that, I think you guys should have this memorized. What is phi going to equal? Do you guys know? How do you find phi? Well, yes, you can. You could use that, but we'll get there. But you guys may already know what phi would be. What's phi? What's 1 over the square root of 2 for cosine and sine? Phi is 45 degrees. Is that right? So you don't always know. I'm going to just remark about this. It's not always, in some sense, that easy. Yes, you would have to use your calculator, but phi is pi over 4, ladies and gentlemen. Is that right? Just going to remark about that. So once you get K and phi, what do you say? Square root of 2 sine x plus what? Pi over 4. Easy breezy lemon squeezy. Easy breezy lemon squeezy? You go, oh my God, Mr. Judge, really? Yeah. Let's give you guys another example. They're going to give you now 3 sine x plus 4 what? Cosine x. We're going to have to write this as a single sine, one sine, just like we did before, right? So all I'm saying is you're just going to use this what? You're going to use this fact, this format I proved for you guys. Okay, you're going to use that. Now, how do you start? Define k. What's k? Okay, you say k now. Remember this? This is A, and then this is B. K is going to equal square root 3 squared plus 4 squared. Square root of 9 plus 16. What's 9 plus 16? So this will be what? 5, okay? K is 5. Okay, you guys okay with that? Easy breezy lemon squeezy? Okay, you got K. What do you guys need to get now? I'll write it down. What is phi now? Cosine phi. What's A? 3. 3. What's K? 5. And what else do we know? Sine phi is what? 4/5. Aren't they both positive? So phi is in quadrant 1. Is that right? All students take calculus? So then here's what we have to ask. Again, we're going to ask the same question, right? This is phi. Now, I'm going to introduce you to you guys. You may know this already. Oops, sorry. You may know this. I need to get phi. This means phi is the inverse cosine of 3/5. This also means phi is the inverse sine. So we're going to have to talk about inverse functions, right? Inverse are reverse functions. We have this inverse what? Functions. -1, -1. Inverse cosine. Second, you see this here? This is the inverse. You guys see? Oh, no, you don't see it. Let me go back. Okay, I'm going to share with you guys this here. Okay, let's find it out. Let's find out what this is. So we're going to say the following. Second, inverse cosine. Inverse cosine of what? 3/5. What do you guys get for phi? This is 35 or 53 what? Degrees. Sorry. Okay, so here's what I want to ask you guys. Since you know this is in quadrant 1, what's the deal? This is quadrant 1. That's the angle. I don't have to check sine because what's the deal? If they're both positive, they're in quadrant 1, and 53 degrees is in quadrant 1. So, ladies and gentlemen, final answer is going to be Okay. You say, what's k here? 5. 5 sine x plus 53 degrees. And there you go. Easy breezy, lemon squeezy. Follow your format. And I want you guys to note something here. You said, what if they had given me 3 sine x? I'm going to share with you guys. 3 sine x minus 4 cosine x. Okay, this is a note. It's another example, but it's a note. Remember, this is still going to be what? A. And this is going to be B. K will be what? Square root of 3 squared plus negative 4 squared. Square root of 9 plus 16. That's still going to give you what? 5 for K. Is that true? So K here is what? 5. All right, you guys okay with that? That's K. So what do you have to answer again? What is what? Phi. So if you go back to these equations now, what changed? Do you guys know what changed here? Yeah, the sign changed. Is that right? For the B value is different. It's opposite. So I want you guys to consider this. This is going to be what? Negative. Is that right? Is that right? This means phi will be what? Inverse cosine of 3/5. We already seen that. Is that right? You said, I did that already. I used that inverse, and I got 53 degrees for phi. Okay? Didn't we get that over here when I used the calculator in the past? This is what I'm saying. We did this. But what do you guys know about phi? You see, this is not the phi. I'm going to write this down. This is not our what? Phi. Does anybody know why? I don't. Yes, let's find out where phi is. Where is phi at? Let's find the picture. You guys remember that? I spent all this time on this picture. Since I spent all this time on it, we might as well use it, right? So all students take calculus. We know cosine's positive, but sine is what? Sine is negative. Is that right? Sine's negative. And what do you know about cosine? Cosine's positive. So what quadrant what quadrant has that? Cosine's positive in quadrant what? 1 and quadrant 4. In quadrant 1, what do we know about sine? Sine is also positive, but in quadrant 4, sine's negative. Is that right? So what do you think this gave us? What do you think that 53 degrees refers to? Right, because you go, Mr. Judge, it gave me 53 degrees. This is a quadrant 1 answer. It's not a quadrant 4 answer. What it gave me is this thing. It gave me the what? The reference angle. It gave me the reference angle, ladies and gentlemen. So since it gave me the reference angle, what is phi really going to be? We can say it two ways. I can say, ladies and gentlemen, that phi is minus 53 degrees. Is that right? I can say it that way. Phi is what? Minus 53 degrees. What else can I say? That's right, 360 degrees minus 53 degrees. And what does that mean about our phi? 307 degrees, ladies and gentlemen. So I just want to kind of remark there, either phi would be good. Yay? Nay? You guys see what I'm saying? So I don't know. I'll pick 307 or minus 53. Okay, so here's what we get now. K is still 5, right? Final answer is 5 sine x minus what? 53 degrees. Here's K. Here's phi. Here's the answer. Easy breezy lemon squeezy. Let's try one more. I'm going to do another one. So a sine. Give you guys another example. Okay? What if they said to me, negative sine x plus 3 cosine x. Okay? This is my, what is this over here? Here's my A, and then what do I have over here? B. A, B. K, square root of what? A squared plus B squared. Here's A. Here's what? Here's B. Square root negative 1 squared plus 3 squared. Okay? Isn't that 1 plus 9? So what is K? Square root of 10. All right, you guys okay with that? No big deal. You got your K. That's the definition. But what do you got to use? Sorry. Choking. We got to use this. Got to use this. And do that. So what's A? -1. What's B? 3. Cosine phi is -1 over the square root of 10. Sine phi is 3 over the square root of 10. Okay, cosine's negative. Sine's positive. Let's find what phi is. Okay, let's go to the calculator because we need phi. Is that true? So how do I get phi? Do you guys want to tell me? Use inverse cosine of -1 over the square root of 10. This will give you your phi now. Sorry, clear that out. Inverse cosine of -1 divided by second square root of what? 10 here. Bring that out there, parentheses. What does this give us? Let's go to the nearest degree, okay? What does that mean to the nearest degree? Is that 108 degrees? Okay, you guys okay with that? You guys see that there? You get to use the inverse cosine key. We're going to learn inverse cosine at the end of the chapter, but whatever. There's your phi. But the problem is all students take what? Calculus. So what do we know here? Right, cosine is what? Negative. Sine is positive. So where is sine positive? Quadrant 1, quadrant 2. Okay? Sine is positive in those two quadrants. You guys okay with that? So does it make sense that phi is 108 degrees? Yes. What's the deal? Right, 90. This is going to be where phi is. Because that's 108. So that makes a lot of sense. Okay? So what's your final answer? Square root of 10 sine x plus 108. You did find the right phi. Doesn't always make sense, ladies and gentlemen. I just want to warn you guys. There you guys go. It's going to equal what? 108 degrees. Easy breezy lemon squeezy. Follow this what? Format. Should we try another one? Should we do another? Or let's do this here. Let's look at your textbook. Oh, I forgot to prove these cofunction identities. You guys can prove it. It's not, whatever. share this with you guys. Just look at the graphing. Minus 3 sine plus 3 cosine, right? Minus 3 sine plus 3 cosine. Let's go to decimals. Or let's do the first one we did. They said, what is the graph of sine? We're going to graph this. Y equals what? Sine x plus what? Cosine x. Remember that first one we did, the first example, y is sine plus cosine? That's the curve. You go, boy, that looks like a sine or cosine curve. Is that right? But remember, what do we do in decimals? Or what did we do earlier, that first example here? Okay, we'll go with the easiest one. It doesn't matter, but what do we find, right? Sine plus cosine, what did it become? It's right here. Okay? Square root of 2 sine x plus the pi over 4. The point I'm making is, can you guys graph that? The answer is yes, you can graph that. Is that right? What's the amplitude? Square root of 2. You guys remember that? What's the period? Blah, blah, blah. You guys remember that? Period is what? 2 pi over what is k? 1? 2 pi. What's the interval of one cycle? What's the phase shift? You guys remember that? Negative pi over 4. Is that right? So you guys can get the interval of one cycle. But if I look at decimals, you say that's y equals square root of 2 sine, right? Sine of what? X plus, what is this? Pi divided by what? 4. So here's what I want to remark. Let me change the color. Let's change this color. Maybe green. I don't know. Are they on top of each other? What does that mean? They're the same, aren't they? Anyway. So, I mean, if they ask you to graph, you say, oh, okay, I know how to graph. Right? So I'm looking at decimals, not decimals, I'm looking at this thing here. Let's do 41 to 44. 1 do what? 12. 41 to 44. 7.2. Assignment. Homework 3. Edit 7.2. We say 1 to 12 all. And then, what do we say? 40 what? 41 to what? 41 to 44, right? So what I'm saying to you guys, I already put online